Hey folks, Darren with Fervent Astronomy with another review of a lens that probably isn't very good for astronomy. Today I have the Nikon Nikkor Z 28mm F2.8 in this special edition to match my ZF. Very, very vain. I'm very vain. I've even got a aftermarket hood that kind of matches. So yeah, it's great. I'm a hipster. I love it. It's so good. Do people use the word hipster anymore? I'm not even really sure. At any rate, I don't expect this lens to be wildly awesome on the night sky. You know, it is pretty much made of plastic. It's got a tiny, teeny tiny little front element. I mean, it's kind of hilarious given how big the rest of the lens is. Like, it looks like it would fit in a chapstick tube, basically. But since we've got this giant Z mount, it needs the whole big thing. Anyway, I'm just getting off topic. So I'm going to test this lens for astrophotography because I can, and I will, and you're here, and I hope you enjoy this. Let's go look at some samples. Hey folks, welcome to Lightroom. Here we've got the Nikkor Z 28mm F2.8, in this case, SE for special edition, because I'm just that type of hipster. There's no real difference there. It's all aesthetic on the outside, but of course it's worth mentioning. So here we've got a few samples. Normally I'll do some tracked and some untracked. In this case, I've got one untracked sample at f2.8, and then I've got 4 track samples as we stop down to f4. Of course, as always, the tracking is done via the LighTrack II from Fornax Mounts. Fervent Astronomy is, of course, Fornax Mounts distributor in North America. So if you're interested in that mount, head over to ferventastronomy.com. You can learn more about it. In the case of all of these samples, these are all taken with the Nikon ZF 24 megapixel camera because that's the Nikon Z camera that I own. I usually like to use a higher megapixel camera, high resolution camera for these, but I'm not about to go buy a Z8 or a Z9 for this purpose. So forgive me, maybe one day, maybe one day. That being said, the tracked shots are all 60-second exposures. Everything is shot at ISO 800. Why ISO 800? Well, it's because of a little something called ISO invariance. Basically, for the Nikon ZF here, every ISO above 800 is just taking the image that the camera gets at 800 and it's bumping the exposure up digitally. Everything, the shadows, the noise level are all identical to what you would get at ISO 800. So by using ISO 800 here, what I'm doing is I'm giving myself the ability to get the same noise level, the same detail in the shadows that I would at a higher ISO if everything else stayed the same. Let's say if I shot this exact shot at a higher ISO, I'm giving myself the same latitude to process it, but also potentially saving some highlights. So if I was doing Milky Way or maybe some aurora or something where there might be a risk that I could blow out the highlights in one part of the image, I might be able to retain some of them better at ISO 800 as opposed to ISO 12,800 or something. So while on the back of the camera, I don't get the bright exposure that I would want as sort of a finished image, I am preserving the ability to potentially capture more information in the image, potentially retain some information, color in the highlights, etc. And to anyone who's blown out the core in something like Andromeda and then had to take a bunch of underexposed shots and then put those in composite and you know why this might be valuable. If you want to learn more about that, hit the link in the description. I'll bring you back to Fervent Astronomy's website, and there's a set of links there, everything you're going to want to know, for instance, revolving around ISO invariance. That being said, there's also a link to download these samples, something I highly encourage. Full RAWs are available. Please download them. Pixel peep process to your heart's content. Hang it on your fridge if you want. But as they are my copyrighted works, even though they're not much of a work of art, they do represent my hard work. So I ask you to please use them in the manner in which they're being provided. Please respect my copyright. Don't redistribute them online or otherwise. Please don't misrepresent them as your own. Please don't use them for your own reviews, etc., etc. Please use them in good faith for the purpose I'm providing them. Thank you so much. So let's take a real quick look here. This is the untracked 15-second exposure at f2.8. When we zoom in, this is a 24 megapixel sensor. Let's zoom it to 400, and you can see we're getting a little bit of star trailing, maybe a little bit of wind. I'm noticing there's some funky shapes. It's possible that there was a little bit of wind that was shaking things around. That being said, this is pretty dark. Let's just bump it up a little bit. Yeah, a little bit of star trailing. Not too bad. 28 millimeters is pretty wide. We can see there is vignetting. We'll get to that more in a second. Would I shoot this untracked? I guess possibly, but you wouldn't be capturing a very clean shot. Obviously, this isn't anyone's #1 lens for astrophotography. but to get a proper exposure, I'm going to recommend some tracking or being fine with some star trails. I know this is a 24 megapixel sensor. It's hiding them. If this was a 45 megapixel sensor, we'd be able to see these star trails a bit more. They'd be more prominent, but here they're spread out over fewer pixels, so they don't appear as noticeable. This is Ursa Major here, obviously, so we're almost pointed, due north. We're straight up there in the sky. There's not like the Milky Way or anything here to provide a little bit more exposure. You can try it if you don't have a tracker and you have this lens. 2.8 is kind of like the minimum that I would recommend as far as an aperture goes. I think this lens is wide enough that it would be kind of okay. Give it a shot. I'm not here to tell you what to do and what not to do. I'm just here to show you what that would result in if you're going to do it. In this case, here is the 60-second exposure at f2.8. So still quite dark. It's not wonderfully exposed, but all those same caveats remain. We, of course, are not pointed at a very bright part of the sky. You can see it better on the navigator, but there is some vignetting, although it's actually not too bad. It's mostly just in the corners. It's not creeping into the center of the frame very much, so that's pretty okay. As far as contrast, I think it's doing okay. I wouldn't expect this lens to have poor contrast. I'm just gonna give it a little exposure bump there so we can see what's going on. Overall, for a 2.8 lens, it's not terrible. We're getting fairly even. Obviously, once we boost it up here, it's a little bit more of a bright spot, but it's not that bad. Let's pop in and we can see right away we've got some blue-purple fringing. This is chromatic aberration. Chromatic aberration because chroma, color, and the lens isn't able to focus all of this light right in the spot that it needs to. That being said, this is pretty innocuous and easy to deal with in post. I don't really see any spherical aberration that I'd worry about. Spherical aberration, you get bloating in the stars. So, I mean, that's a plus. And let's see, let's go look in the corners here. Boom, we do have space birds. Some of you might look at these space birds and immediately go, oh, this lens is coma. This, friends, is not coma. These space birds are caused by astigmatism. So real quick distinction, coma is if you have stars that kind of blur out into like a fuzzy wedge. So you'll have the star and then it might be a little bit delta shaped and it'll get a fuzzy tail behind it. That is coma, named after comets, otherwise chromatic aberration, the official term. If it's pointed the tail away from the center, it's external coma. Toward the center, it's internal coma. Here, I don't see any. Here are space birds. This is astigmatism. So we have tangential and sagittal astigmatism. Tangential astigmatism will be along axes radiating from the center of the frame, and sagittal will essentially ring the frame. It's more or less going to be at a right angle to the tangential. So even if things curve a little bit, it'll always stem from this axis right here, as opposed to this tangential one. So you will get these space birds, and this one's kind of pretty for what it is with the chromatic aberration around it. The way that these affect things at normal people viewing distances is that if it's really bad, it'll make stars around the edges look bigger than stars in the center of the frame. And it does appear to be happening a little bit. You can make note of these. It also plays along with the typical underexposure and vignetting you get around the edges, where it'll be darker out here, and thus the brightest stars will be the ones that are visible for that particular exposure, and they'll more than likely be bright enough to turn into these astigmatic birds, and the other stars would be too dim to even really show up. So it sort of accentuates the issue. We got more stars in the middle, less stars around the edges, and it appears like there's bigger stars around the edges because there's nothing to even them out. This is not uncommon. This is completely expected, especially from a lens with a plastic lens mount. We're not dealing with, really high test optics here, but overall is totally usable. If I didn't explain all that to you or to, some random photo appreciator, you might not even know about it or notice it or have anything to say about it. So keep that in mind. This is art after all. We zoom into the middle, take a look at the star sizes, nice and tight, go to the side. They are stretched out, but they're not getting bigger, which is what I'm looking for. The stars aren't looking fuzzy. They do, of course, have the astigmatism, but they're not looking defocused. So what I can confidently say about this lens is that this lens doesn't appear to have a ton of field curvature. That's something that you get more, I would say, in faster lenses or older lenses, and that is when let's say the center of the frame is in focus, but the edges and corners are not, or vice versa. So if you focused here, it might be out of focus around here. If you focused in the corner, it'd be nice and sharp, but in the center, it'd be out of focus. So that's field curvature. Not really a ton happening here. Let's scroll through these really quick. Just gonna put that exposure back down. This is f2.8, 3.2, 3.5, f4, real dark. We'll just take a look at the astigmatism here. F4, 3.5, 3.2, and 2.8. Gonna be honest, I don't see much point in stopping down. While it is cleaning up the sagittal astigmatism a little bit, it's getting so dark that I just don't really see it being too useful. I know if anyone's gonna use this lens for astrophotography, you're likely gonna use it on a tripod wide open anyway. Save yourself some headache, keep it wide open, and we'll try and deal with any other things here in post. So let's go to the develop module. First, let's zoom in here, remove chromatic aberration, which never seems to work on the stars like this. We're gonna get our little diffringe dropper, click on that blue purple, and boom, gone. Very clean, you know, almost looks monochrome. So there's that, but you can see there is some star color still around. That will deal with that very handily. I'm gonna brighten it up here a little bit because we need to actually be able to see things. Now, this is the portion where I would typically come in here and enable profile corrections, but do you see this? Built-in lens profile applied. So this lens already has the profile applied to it. There's not a profile in here that I can do, and I don't get the choice to turn it off. So while we can't, you know, click a button and change the geometry, this means that the geometry should actually already be okay. And what is happening here is this is what you would call a quote unquote electronic lens element. This has been designed into the optical formula, if you will, that the lens has to have a correction applied by default to give us an acceptable image. The other lens elements, the whole formula, is designed with this as part of the optical train. So this is not something that we can turn off. However, that doesn't really help us with the vignetting. So we're going to come over here, we'll go manual, vignetting, and we're just going to see if we can improve things a little bit. Here it can be a little tough to find the sweet spot. Sometimes you have to do a custom mask, gradient mask, but if you look at the navigator, it's okay-ish. So this is a possible solution for you. That being said, no profile to worry about. So I can't really comment on any of the distortions. So that ends this portion of the video. What did I tell you? I'm not sure if I told you anything. Are you surprised, really though? All things considered, I hope this was at least fun to watch, a little bit informative. Maybe you're going to consider giving this a shot yourself. You know, at f2.8 and 28 mils, you know, it's just on the edge of being wide and fast enough to be kind of useful just for like a time lapse or something to that effect. Of course, it need to be tracked, but we've done that for posterity, right? But yeah, I mean, this just makes me happy. This is one of those little joy lenses. And yes, it is because it looks cool on my camera. Thanks for watching. Hopefully we'll see you next time. Take care.